About to start a lab on the projectile motion. You will be using a PhET simulation from the University of Colorado. As you know, an object that has a constant horizontal velocity and a constant vertical acceleration is a projectile. We will go directly to the screen and familiarize ourselves with the screen. You will notice that the lab contains a cannon. I'm pointing to the cannon, which can shoot various projectiles. You can see up there on the right the tank shell, the golf ball. And at the bottom of the screen you will see a silver box with a yellow circle, and this is the adjustable tape measure that allows you to measure the distance. Now here you can move the cannon, change the direction of at which the cannon is pointing. You can set it to a horizontal level. If you look at the toolbar on the right, you will see the choices you have. For the purpose of this lab, you will select the user choice. Throughout the lab, you will keep the angle at 0. For the first part of the lab, you will use an initial speed of 18 meters per second. You will not change the mass or the diameter, and do not select air resistance, because that does not give us a true reflection for the slab. As you can see at the bottom, we have a choice to fire or erase, and we can use sound if we want to. You can see at the top the 3 little boxes. The range, or M, is the distance the projectile travels on the x-axis, meaning horizontally. The height is what it travels, or rather the equivalent on the y-axis, and the time it takes to reach the ground. You can go to the cannon. You can move it to the right, move it to the left, move it up, whatever you want. It's your choice. The tape measure here measures horizontally. We can go up here. It measures vertically also. This height is your choice. For the first 5 readings, you will keep the initial speed as 18, but you will just change the height of the cannon. So we can start somewhere here, not too high, and let's say here, and then you fire, and on your table, which I will be giving you a sample of, this is trial 1. The speed is 18 meters per second. The range, or the x value, is 16.2. The y value is 4.0. Erase, and then you can raise it a little and fire again. Again, the speed is the same. Oh, this is a perfect score. It landed on the target. You can see the y reading, the x reading, the range, the y reading, the height. No need to look at the time at this point. I'm going to erase it, and I'll do 3 more at the same initial speed of 18, but I'm only changing the height. So there's 5 readings here, 5 trials, where the angle stays as 0, the speed as 18, and I'm just recording the range and the height. The range being the x-axis reading and the height being the y-axis reading. In the second set of, on the second table, you will keep the height constant. You will not change it. I can move this back now. I don't really need it at this moment. And you will keep the height constant, but you will change the speed. So from 18, how about I just go down to 10 and I fire. And so my new table will have trial 1. The speed is 10. The X value is 12.9. The Y value is 8.1. And the time is 1.3. I'm going to erase that. And I'm going to change the speed to 15. And I'm going to fire. And again, oh, that's another good shot. You can see it hit its target. Again, trial 2, the initial speed is 15, the X value is 19.3, the Y value is 8.1, and the time it takes is 1.3. So get 3 more readings. You could maybe go to 20, change the speed from 15 to 20. Get your readings from 20 to 25. Get your readings, maybe 25 to 30. So you will have 5 different speeds in this table, but nothing else will change. Complete the 2 tables by playing with this simulation, and then create the graphs that are asked for in the online text, in the instructions. Create the 2 graphs, copy and paste them onto Word, and include all other requirements for the lab. So if you have any questions, please webmail me and I will get back to you.